Good morning, guys. Myself Sridharaj, working as assistant professor in the Department of Electronics and Communication at Government Engineering College, Haveri. So today we are just going with the subject basic electronics. In that module 1, semiconductor, diodes and application. In this, the last session, that is the 7th session, applications of diodes. Okay, so where all the diodes are being applied. So photodiode, LEDs and all those stuff. So first thing is we just going with the photodiode. So what is this photodiode? A photodiode is a PN junction or a pin semiconductor, that is PIN semiconductor device that converts light into an electrical current. So the photodiode is the one which converts light into a electrical current. It is a special form of PN junction diode that produces current when the junction is exposed to radiation. So this one, so when does this light is being converted into electrical current is whenever it is being current when the junction is exposed to the radiation. It is also called a photodetector or light detector and a photo sensor. Okay, so normally it will be telling it as photodiode. The symbol of a photodiode and the two inverted arrows represents it is exposed to radiation. See, yeah. So this one is a photodiode and this one is the exposed to radiation. Okay, so working of a photodiode. Photodiodes are specially designed to operate in reverse bias condition. See, the negative terminal is connected to P type and the positive terminal is being connected of a voltage source to a N type. So this one is the positive ion and this one has the negative ion. So these are the free electrons as well as the holes. So this one is the depletion region and this has been the widest depletion regions, and this one is the operating for a reverse bias condition where the radiations will be just taking place. So working of a bias. So this one, so the depletion region wherever it will be having, so there the radiations take place which emits the light, so which converts into a light into a electric current. So how does working of a photodiode? When reverse bias voltage is applied to a diode, only a small current flows through the device, that is due to the minority carriers, and the current is called a reverse current. So what is minority carriers, and this current is called a reverse current. When the junction is not exposed any radiation, a very small reverse current flows through the device, that is termed as a dark current. So when the junction is not exposed any radiation, a small reverse current will be flow, then that one is known as your dark current. Dark current flows through the device in the absence of any type of radiation. So what do you mean dark current? So there is a light flow of current, so when there is no radiation. At certain point of time, the movement of magnetic carrier creates a depletion region across the junction. The depletion region contains neutral atom which does not allow any flow of electrons and holes across the junction current. Now the junction is illuminated with the light. As the light falls on the surface of the junction, the temperature of the junction increases. This causes the electron and hole to get separated from each other. See, so at this point, so when the radiation has been taking place, at this point the holes and the electrons will be just changed and separated from each other. Next, the electron from the N side gets attracted towards the positive potential of the battery. Similarly, holes present in the P side get attracted to the negative potential of the batteries. Here, negative terminals are connected for the positive terminal and the positive terminal is connected towards the negative terminal. This causes higher reverse current to flow through the device. With the increase in the light intensity, more charge carriers are generated, which produces a large electric current through the diode. This current is then used to drive other circuits of the system. The intensity of the light energy is directly proportional to the current through the device. Only positive bias potential can put the device in no current condition in case of the photodiode. In a photodiode, when there is no incident light, the reverse current is almost negligible and is called a dark current, and the presence of dark current decreases the sensitivity of the photodiode to light. Okay, so these are some of the characteristics of the photodiode. The figure below will be a characteristics of the photodiodes. Here the reverse bias condition, to in the forward bias. So how it is being just go on increasing. The y-axis represents the reverse current flow through the device, and the x-axis represents the revised bias potential here, x and y. The first curve represents dark current that generates due to minority current in the absence of light. So this one is the dark current. So when there will be no flow, when there will be no radiation, so there will be a small leakage current. So this one is known as the dark current, and all the curve are almost equally spaced here. This is because the proportional increases with the intensity of light. Okay, see the space is being equally thin. So where are the photodiodes are being applied? So photodiodes are used in simple day-to-day applications. The reason for this prominent use is there the linear response of the photodiode to light illumination. Okay, photodiodes with the help of optocouplers provide electric isolation when two isolated circuits are illuminated by light. So this one with the help of optocoupler provides electric isolation when two isolated circuits are illuminated by light. Optocouplers are used to couple the circuit optically. Optocouplers are the fast compared to conventional devices. So photodiodes are being used along with the optocouplers. Photodiodes are used in safety electronics such as fire and smoke detectors. So smoke sensor as well as the fire sensor, the photodiodes are used for the safety of electronic goods. Photodiodes are used in numerous medical applications. They are used in instruments that analyze samples, detectors for computer terminology, and also used in blood gas monitors. So almost in all the medical applications, these photodiodes are being used. So these are some of the small simpler applications of photodiodes. Photodiodes are used in solar cell panels, and it is also used in logic circuits, in detection circuits, in character recognition circuits, and this is also used for exact measurement of the intensity of light in science and intensity. Photodiodes are faster and more complex than normal PN junction diode, hence they are frequently used for lighting regulation and optical communications. Because the photodiodes are very much cheaper, so it is used in almost all the things. So what are the advantages? The advantages of photodiodes are the photodiode has a battery frequency response, linearity, and spectral response than LDR, that is a light detecting resistor. Photodiodes is suitable in instruments that test the laser pulse shape. It can operate at high frequency in the order of 1 MHz. It can also be used in variable resistance device. It is highly sensitive to light. It has lower noise, faster photo detector. That is, the noise effect is very much smaller and faster photo detector. So what are the disadvantages are? The disadvantages are it has a rapid increase in dark current with temperature. It has a small active area. This is necessary for applications at low irradiance. It needs offset voltage. So these are some of the disadvantages. So next is your LED, that is light emitting diode. LED is an acronym for light emitting diode. The light emitting diode is a two-LED semiconductor light source. So LED is a two-LED semiconductor light source. It is specially doped diode and made up of special type of semiconductor. The LED is a special type of diode that have a similar electrical characteristics of a PN junction diode. The LED allows the flow of current and in the forward direction and blocks the current in the reverse direction. What is this? LED allows the flow of current in the forward direction and blocks the current in the reverse direction. The construction of LED is similar to the normal PN junction diode, except that gallium, phosphorus and arsenic materials are used for construction. However, silicon and germanium diodes are not used since they do not emit energy in the form of light. Instead, they emit energy in the form of heat. The symbol of LED. So this one is a symbol. So where the radiations have been going out in the what photodiode, the radiations have been outside, inside, and in LED the radiations are been outside. So why is this? Silicon and germanium iron means it is the emitting energy in the form of heat, but gallium, phosphorus and arsenic materials are being formed in the form of light. Okay, so this one is the working of LED. So the P type has been connected with the positive terminal and the end voltage source, and the negative has been connected towards the negative source. So it is the forward bias condition. So here the depletion region is being formed. So this one is the formed recombination of free electrons and holes. So here the emitted photons or the emitting of lights is being taken place. Okay, like an ordinary LED, the LED works when it is in a forward bias. When a suitable voltage is applied to the LEDs, electrons will recombine with holes within the device, releasing energy in the form of photons in all directions. This effect is called electroluminescence, and the color of light corresponding to the energy of the photon is determined by the energy band of the semiconductor. Okay, so what are the means? When so applied, the radio electrons will recombine with holes with the device, releasing energy in the form of photons in all electrons, and the color of the light is dependent upon the electron sensors and the energy of the photon. When a p-n junction is forward biased, the charge carriers recombine as these electrons cross the from the n region with the holes existing in the p region. Free electrons are in the conduction band of energy levels, while holes are in the valence energy band. Okay, so this one is just the p-n junction. So when a charge carriers recombining, what will happen with the n regions with the holes existing in the p regions, and in the free electrons are in conduction band of energy levels. Thus the energy level of holes will be lesser than the energy levels of the electrons. Some part of the energy must be dissipated in order to recombine the electrons and the hole. This energy is emitted in the form of heat and light. So whatever the dissipated energy will be there, that to come the electrons and the hole. This energy emitted in the form of heat and light. The electron dissipate energy in the form of heat for silicon and germanium diodes, but in LED the electron dissipate energy in the form of light. In LED, gallium arsenide, phosphonate and gallium phosphide semiconductors are used which can dissipate energy by emitting photons. Okay, in LED, so what are the materials will be normally is gallium arsenide, phosphide and gallium phosphide are the materials for it is being used. If the semiconductor is translucent, the junction becomes the light and it is emitted, thus becomes the source of the light, and as it is emitted, thus becoming a light emitting diode. But when the junction is reverse biased, no light will be produced by the LED. So here there will be no light when only the photo means LED will be just only for the forward bias, not for the reverse biased. Okay. Next, so what are some of the advantages? The brightness of the light emitted by LED depends on the current flowing through the LED. Hence, the brightness of the LED can be easily controlled by varying the current. This makes possible to operate LED display under different ambient lighting conditions. Okay, so in the general, if you just take the bulbs, what it was been previously used, so it was been operating for only for a specified voltage, but the LEDs, so if you just increase the current flow, it will be just growing brighter, and if the voltage is being reduced, then it will be in the uh, lighter mode. So that is the main advantage of the LED. LED is the very cheap, readily available and consume low energy. Why people are going for LEDs are very cheap, readily available and consume low energy. LEDs are light in weight, small size and longer life. LEDs operates very fast. They can be turned on and off in very less time. LEDs can emit different colors of light. LEDs can emit in different colors of light, and they lightly operate very fast. They can be turned off and on and off in very less time. Next, so disadvantage of LED needs more power to operate than normal PN junction. Luminance efficiency of LED is low. So applications of LEDs, almost in all the electronic goods we are just finding LEDs. So some applications are bulb alarm systems. So we'll be using in calculators, picture phones, traffic signals, digital computers, multimeters, microprocessors, digital water watches, automatic heat lamps, camera flashes, aviation, lighting. In normal bulbs you can take it as, nowadays we are coming across LED TVs, LED watches, okay, LED wristwatch. So almost the whole world is being totally replaced by LEDs right now. Okay, next, optocoupler. An optoisolator or an optocoupler is a device that transfers electrical signals between two electrically isolated circuits through light energy. So optocoupler means it is passing the transfer of the electrical signal between two electrically isolated circuits through light energy. Okay, optoisolators prevent the high voltages in one part of the circuit from affecting or destroying other parts of the system. It is just avoiding one part of the circuit from affecting or destroying other parts of the system. Construction. Optoisolator is a device which has two diodes. One is source or emitter of light, usually a light emitting diode, and the other is a photodiode acting as a photo sensor. So we are using two diodes. One is LED and another one is a photo sensor. The LED converts an electrical input signal into light, as we already know, and the photodiode detects incoming light, and based on the incoming light either generates corresponding electric energy. So this one is opto means two pumps, that is LED as well as a photo sensor is being used. So this one is a basic optical. So this one is a LED, so it is been generating, and this one is a photodiode, it is been taking back. So LEDs are been generating this one, and the photodiodes are been accepting the light signal whatever it is getting, and that converts the thing. Working principle is simple. The output signal of one circuit can be controlled by varying input signal in the circuit where the two circuits are electrically isolated. A powerful light emitting LED is connected across a variable voltage source. By adjusting the input voltage across the LED, the intensity of the light emitted from the LED can be controlled. The variable source and the LED from input circuit of the optocoupler of the optoisolator. So photodiode is present in front of the LED so that the light emitted from the LED directly strikes the junction of the photodiode here. So LED is directly striking the photodiode. The photodiode is a reverse bias condition. The reverse bias circuit of the photodiode forms the output circuit of the system. It is also ensured that there is no other light falling on the photodiode junction, and the system is protected from any external light except the light coming from the LED, because the photodiodes, whatever the light will be just getting or radiations or a heat, it will just start operating. So what the care should be taking is only the LED light should be falling on that photodiode, not the any other lights. It is also that there is no other light falling. Okay, initially no voltage is applied to the LED, hence the LED does not glow. In this condition, as no light falls on the photodiode, there would be only dark current flowing through the output of the circuit. During current in the reverse saturation current of the reverse bias photodiode, when it is entire dark, this is unavoidable reverse leakage current of the diode. Now if we increase the voltage across the LED starts glowing, and at the same time intensity of the light increases with increasing input voltage across the LED. With increasing light intensity, the reverse current in the photodiode increases. Since the reverse current in the photodiode is linearly proportional to the intensity of light falling on the photodiode junction. Also, if we decrease the intensity of light in the input, the output photodiode current will decrease. So some of the applications of the optocoupler are, so in lab ballasts, light dimmers, wall war motor controllers, microcontrollers for infecting with high voltage circuit. So these are some of the applications of the optoisolator or the. So now the advantages and disadvantages of the optocoupler. Advantages are, it offers very good response at low frequencies. Compact and cheaper optical devices are available, and the disadvantages are optocoupler needs external biasing voltage for its operation, that is the main disadvantages, and highly frequency and higher response is poor. The frequency response is been poor, but the advantages is very good at lower frequency. So now the last bit, that is a fixed voltage regulator. The fixed voltage regulator has an unregulated DC input voltage VA applied to one terminal at a regulated output DC voltage V0 from a second terminal and a third terminal connected to a ground. The fixed voltage regulator is having two terminals, input terminal, ground terminal, as well as the output terminal. The first terminal is known as the input terminal, the second terminal is represented with the ground, and the third terminal is being connected with the outputs here. The numbers is being represented, and this is the notch what it is being represented. Okay, so this 1 represents the input, 2 represents the ground, and 3 represents the output. So this one is the internal structure, that is a 78XX. It's a series. Okay, positive input, ground, positive output. The three terminals 1, 2, and 3. Regulators are the three terminal device that provide a fixed positive output voltage. Okay, so unregulated input voltage Vi is filtered by the capacitor and connected to the IC in terminal. The IC out terminal provides a regulated 12 volts voltage which is filtered by a capacitor. Means regulators are being used when if we are having less voltage, we can be increased to a maximum voltage, that is of 12 volts. Third HN is connected to a ground, in, out, as well as the ground. So in also it is having connected with the the capacitor filter, and for the out also it being connected with the capacitor filter, and the third pin is being connected for the ground. Fixed voltage advantages. The 78XX series ICs do not require additional components to set their output voltage. So it does not require any of the additional components. So 78XX series are simple in comparison to switch mode power supply design. The regulators have been used in comparison to switch mode power supply design. So whenever we want to increase the voltage, at that time the regulators are being used. So 78XX series ICs have built-in protection against a circuit drawing too much current. Okay, so it is having a built-up protection that draws the too much current. They have protection against overheating and short circuits, making them robust in most applications. So they have protection against the overheating and short circuits. Normally the regulators will not be shorted. So these are some of the disadvantages. Input voltage must always be greater than the output voltage. That is, if 5 volts output from the input voltage must be greater than 7.5 volts. That is, so input voltage must always be greater than the output. Whatever the output voltage you will be getting, it should be more than the input voltage. So these devices cannot be powered from certain power sources. That is, 7 cannot be powered from a 6 volt. But as the voltage output is 7 volts, it will not be having with the 6 volt battery. Means always the output should be increased. So sorry, the input should be increased. Input current required and the output current of the series is same. Input current required and the output current of the AC is same, but the output voltage is always less than the input voltage, which means some amount of power is dissipated as heat inside the regulator. So proper heat sinking mechanism must be implemented. Okay, what means the output voltage, whatever it means, it should be less than the input voltage. What are the output voltage we are having? It is less than the input voltage. So which means some amount of power is dissipated as heat inside the regulator. So proper heat sinking mechanism must be implemented. This loss of power also decreases the efficiency of regulators. Okay, so the form of the features of 78 regulators are, so it's a 3-terminal regulators, as already we people know it, input, ground, as well as the output. Pin number 1 represents your input, pin number 2 represents your ground, and pin number 3 represents your output. Internal short circuit current limiting, output current up to 1.5 amps, output transistor safe area components, internal theory overload protection, and high power dissipation capability. Okay, so these are some of the features. Applications of voltage regulator. Current, it can be applied in current regulator, regulated dual supply, building circuits of phone chargers, UPS, power supply circuits, portable CD players, etc. So these are the voltage regulator, where it means normally what the phone chargers, whatever people have been using, UPS, power supply circuits, and portable CD player, fixed output regulator and adjustable output regulator, etc. So these are the some of the applications of the voltage regulator, that is 78XX series. Okay, so it is having a 3 terminal. Okay, and the whatever means the output voltage is always less than the input voltage. Okay, and the main thing is the current sinking facility should be, that is the heat sinking mechanism must be implemented. Okay, so this completes your session 7, that is applications of the diode, photodiode, LED, optocouplers, as well as the fixed regulator, that is of a 78XX regulator. Okay, so this completes all the 7 sessions of your module 1, that is semiconductor diodes and its applications. Okay, so you can just go through the notes, PPTs, as well as some of the MCQs are being given for every sessions. Okay, you can just try to attend it and try to self examine how much people have been understood from this concept. Okay, thank you.